Hi, and good morning. Here we want to do a rather tricky integral, which I've deemed to be of the scholarship level. And the integral in question is the integral between 0 and infinity, e to the minus ax sine bx over x dx. So first step, we're going to work out a different integral, and let I equal the integral between 0 and infinity, e to the minus ax cos bx dx. And we use integration by parts to do that. So the next step is the first, which is e to the minus ax times the integral of the second, which is sine bx over b, evaluated between the limits infinity and 0. It actually comes out to 0, that does, minus the integral between 0 and infinity, minus a e to the minus ax sine bx over b dx. So I left out the dx there. Okay. Now, that moving on from there, as I said, the first part of that comes to 0. So we now have a over b integral between 0 and infinity, e to the minus ax sine bx over b integrated with respect to x. And so, again, we need to use integration by parts a second time. We take the a over b outside and then the curly bracket, and then inside applying the integration by parts formula again. We have the first, which is e to the minus ax, times the integral of the second, which is minus cos bx over b, evaluated between the limits infinity and 0, and then minus the integral between 0 and infinity, and differentiating the first part becomes minus a e to the minus ax, and integrating the second part becomes minus cos bx over b. So that comes down to, quite easily, a over b, curly bracket, 1 over b, minus a over b times I. And so I is equal to a over b squared minus a squared over b squared I. And getting all the i's onto one side, we have I bracket 1 plus a squared over b squared equals a over b squared, which means I equals a over a squared plus b squared. So in other words, the integral between of e to the minus ax cos bx dx between the limits 0 and infinity is a over a squared plus b squared. We now come to the second step, which is to integrate both sides with respect to b, so, and between the limits b and 0. So I've written that down, integral between 0 and b, db, integral between infinity and 0, e to the minus ax cos bx dx. And that's then equal to the integral of the right-hand side, which is a db over a squared plus b squared between the limits 0 and b. And that's a standard integral, which is tan inverse b over a. Now, if we look at the left-hand side of that, we want to reverse the order of integration, and that becomes the integral between 0 and infinity dx, integral between 0 and b, e to the minus ax cos bx db. And that's a fairly easy integral. That will be e to the minus ax sine bx over x dx. And so the result is tan inverse b over a. And that does it. Thanks very much for listening.